practical we are doing, try to equilibrium of forces. Last week we did the theory aspect. We did theoretical aspect of what we are doing now. So we are just we are going to practicalize what we have done. So we apply the principle of moment. I hope you still remember the principle of moment. You remember it. So that anti-clockwise moment is what? Some anti-clockwise moment is equal to what? Some of clockwise moment. So we use that to do what we want to do. So the aim of our experiment is to determine the stability of the meter rule. We want to know how stable the meter rule be. That is what we want to determine. So our apparatus, if you check the manual, we have the meter rule. This is the meter rule. We have knife edge. We have, this is what we use. We have all these ropes. Then we have set of masses. Then we have 50 gram, 100 gram, 150 gram, 200 gram, and 250 gram. That is what we are going to use. Following what is written in our manual. 3. Suspend the meter rule horizontally on the knife edge. Adjust the knife edge to a point G. G means what? Center of gravity. So on the meter rule, where it balances horizontally, so we want to determine the center of gravity of this meter rule. So this is a uniform meter rule. The length is 100 centimeter, which is 1 meter. So what we do, we are going to balance it on the knife edge until it balances. So when it balances, we check the point at which it balances on the knife edge. Then we are going to record the point as G for the meter rule. So look at what I am doing. So you must make sure it balances. So this meter will balance on 50 centimeter. So that is the center of gravity of this my meter. So you record it G according to my meter rule. G was found to be 50 centimeter. Step 4. Record the distance. The distance D equal to A G, which is what I just did now. The distance D, that is when I place it. If you check your manual, this is A, this side is B. Are you seeing it? And distance from A to the center of gravity is what? D. So which D is A G. So we have to measure, or we have to record the distance. And that is 50 centimeter, which is what I've just written there. Then 5. Suspend the weight hanger securely at a point P on the meter rule such that AP is 5 centimeter. So instead of weight hanger, I'm using a rope. So I'm going to suspend the rope on the 5 centimeter. If you check your meter rule, we have 1 to 100. So on the 5 centimeter, that is where I'm placing it. And the rope will be there until you finish everything. So which means you are not removing the rope from that 5 centimeter. Then 6. Add a mass M equals 50 centimeter. So I will take 50, then add it. Make sure the rope is on the 5 centimeters. So I've added the 50, then adjust the knife edge to a point K or the meter rule such that it balances horizontally as shown in the diagram. So the next thing we are going to do, this is where you need to be careful. So you balance the meter rule or the knife edge to make sure it balances. Then you record the point at which it balanced. The first one we did, there was no mass on it. It balanced at 50 centimeters. Now, since there is mass on it now, it's not balanced at 50 centimeters again. The balance point is going to reduce. So which means as the masses are increasing, the balance point is what? Reducing. So that is what will happen. So just look at what I want to do. This thing can be stressful, but you have to okay, so that's balanced now. So checking my, this is how you will do it until it's balanced. It must not shake, it must not fall, it must balance, not fall. So checking it now, this is 37 centimeters. So yes, you see now that the balance point have changed from 50 to 37. The weight, you place it there to not balance. You have to place it until balance. Anywhere you can put it anywhere, but make sure it's balanced. It must not fall. So when I did it, it gave me 37 centimeters. So which means when I added the mass of 50 grams, the G changes to 37 centimeters. Now, for us to draw our table, because you know your report will be on table. So what are we going to put on that table? Leave it. What are we going to put on the table? G, M is the masses. So the first mass was 50. So here will be 50, 100, 150, 200, 250. And make sure the rope does not move from that 5 centimeters. So the balance point will reduce again. Okay. Don't worry, when you start sweating, I'll be laughing. Don't look at me. So you still moving. You have to wait for it to balance. So this is what I have here. I have 29.4 centimeters. So that will be Z. That is 29.40 centimeters. Do 10 decimal places.
So the 5 centimeters.
I said that AP is constant, 5 centimeter is constant. Which one will they give us? The practical is not always the same now. For this one, AP is constant.
But in another practical,
It will not be like this one. Depend on, you check this one. Check this one. Which one is God bless you? Now, are you using my ruler? Of the graph. Determine the slope S of the graph. You determine your slope from your graph. Then determine the intercept C. Who did not know intercept? Then 14. State 2 precautions taken to ensure accurate results. Then the B. Under what condition is an object said to be in a stable equilibrium? We did it last week. So that is it for today's practical. So it's left for you to start. Somebody from that place should come here. Someone from that table. Last table.